going to be reviewing area in geometry. So two-dimensional geometry with area. This is a review. It's in the 6th grade book, and it's in chapter 10, section 1, this first part of the 6th grade Math and Focus. It's the pink book when you go online if you need extra practice. Remember, the website is my.hrw.com. The username and password is mvmath2. So if you need extra help or explanation, come see me or go to the textbook online. You're going to have to go online because you don't have the 6th grade pink book. So area, two-dimensional. Area is finding how many square units can cover a two-dimensional geometry figure. So we're starting off with triangles, as you can see here. Any side of a triangle can be called its base. The perpendicular distance from the base to the opposite vertex of the triangle is called the height. Well, perpendicular means 92 sides meeting at 90 degrees. Here's that perpendicular, 90 degrees. You look for that box. That box represents the 90-degree perpendicular. So the height is drawn from the vertex down to the base at a 90 degrees. Well, this happens to be a right triangle. So my height is actually a side of my right triangle. So my base and my height of my triangle here on the screen one are labeled. The area of a triangle's formula, 1/2 base times height. Area equals 1/2 base times height. Some people will write that as area equals base times height divided by 2, because multiplying by 1/2 and dividing by 2 mean the same thing. So on page 78, find the area of this green triangle. So again, our height is the perpendicular distance. So here's the box. There's my 90 degrees. So I know this is the height of my triangle, which it's measured outside here, 14 centimeters. And my base down here is 10 centimeters. So how do I find its area? I use the formula. Area equals 1/2 base times height. And now I plug in the numbers that I know. I know the base is 10 and my height is 14. So what is 1/2 times 10 times 14? Well, multiplication is commutative. So I could do this several ways. I could say, oh, I'm going to take half of 10 first, which is 5. 5 times 14 is 70. Or I could take half of 14 first, which is 7. 7 times 10 is 70. Or I could multiply 10 times 14 first, 140, and take half of that, which is 70. So my answer is 70 centimeters squared. Area is how many square units could it take to cover this 10 by 14 triangle here. So it's going to take 70 square centimeters. All geometry requires these steps. Writing the formula, so you'll hear me say this over and over again. Showing the plug in the values that you know, the replacement step. Get an answer and make sure that it has a label on it. Formula, plug in, answer, label. In triangle PQR, PX is perpendicular to QR. So here's my 90 degrees. My height is 25. My base is 30. Sometimes the text will add another number on here. And students will think that, oh, my base is really 40. They add that little extra number in there. That is not part of the yellow triangle here. That's not part of the base. So we're not going to use that. My base is 30. My height is 25. So finding the area of this triangle, and yes, PR is not the height. That slanted side is not the height because that's not 90 degrees down here. That's a big obtuse angle. We have an obtuse scalene triangle here. PX is the height. As you can see, that's what I labeled it because that's the perpendicular, the 90 degrees, that box. So I'm going to use 25 and 30 in my formula. So I'll come over here. Area equals 1/2 base times height, which is 1/2 the base of 30 and the height of 25. Well, 3 times 25, I know that. That's 75. Put a 0 on it, it's 750. Take half of 750, that's 375. Or I could have said, oh, half of 30 is 15. 15 times 25, or 15 quarters. 15 quarters, 12 of them is $3, and 3 more would be 75. 375. Didn't need a calculator. And sometimes, yes, it's easier to just use your calculator. So my answer, formula, 1/2 base times height, plug in the values, get an answer, 375, label, feet squared. Our next problem is the area of a triangle XYZ is 36.5 square centimeters. Find the base of the triangle in this problem. Oh, so we don't have base and height. They're giving us area. We're going to do some equation solving. So area equals 1/2 base times height. I know my area. This is my big capital A. So I'm going to plug that in on the left side here of my equation. I know 1/2 because that's in the formula. My base, I don't know what the base is, so I'm just going to call it the B. And my height, because there's my 90 degrees, that's my perpendicular. Here's my box here. So this is my height of 10. So what is 1/2 times B times 10? Well, the only thing I can take half of is 10, so I'm going to do that. Half times 10 would be 5. Still don't know the base, got to solve that. So 36.5 equals 5 times what number? It's a multiply equation. Divide on both sides. So yes, we're going to be doing some algebra in our geometry. And you get 7 3/10 equals B. Well, got to put a label on that. 7 3/10 centimeters. We are just measuring the length of the side. We are not covering. That's the square centimeters. That's in the area answer. In just one of the dimensions, either base or height, it's just labeled with just centimeters. We're only measuring from Y to Z, one dimension. So it's centimeters to the first power. We don't write first power, that one dimension that we're measuring from here to here. Okay, so we're going to do some equation solving. That was on page 81 in the pink book. 10.2 in the pink book is the area of a parallelogram. The formula for the area of a parallelogram is just base times height. The basic geometry formula, the one that Euclid started with. This is his favorite shape, the parallelogram. The height of the parallelogram is DE. Again, why? Because here's the perpendicular, there's the box, there's the 90 degrees. This is the height, 4 centimeters. It is not DC, this slanted side, not DC. It's not perpendicular. Sometimes the height is drawn outside like it is here. Sometimes they'll draw it from this vertex. Get it over a little bit more. They'll draw it from vertex A and they'll draw the height right inside. Inside the parallelogram. So this is also the height, which would be 4 centimeters. So heights can be drawn inside or outside of the figures. Just look for the box. That's the height. The base is where the height goes down to. So this 8 centimeters is the base here. This 5, I don't need that for area. I might need that for perimeter, but I don't need it for area. I just need base and height only. So that 5 is not going to go in my formula. My formula only has 2 numbers in it, number B and number H. Remember, those are numbers. So to find the area of this parallelogram, write the formula, area equals base times height. My base is 8, my height is 4, so my area is 32 centimeters squared. Formula, plug in, answer, label. Page 90 in the pink book, we have this green parallelogram. Find the area of each parallelogram. Again, this 13 and this slanted side, not my heights. My height, there's my box. My height is right here, 12, and my base is right here, 21. So area equals base times height here. 21 times 12, and 21 times 12 is 252 centimeters squared. Formula, plug in, answer, label. Inside here, my height, this is my height, there's my perpendicular box. So base times height, my base, the box sits down here on the base. So my base is 24. So formula, area equals base times height. And yes, you can use calculators. 24 times 14 and a half. 24 times 14 and a half is 348 inches squared. Parallelograms a little easier than triangles. On page 91 in the pink book is the trapezoid. The parallel sides in a trapezoid are called its bases. One base is usually labeled base 1 and the other one is labeled base 2. The perpendicular distance between the bases is the height of the trapezoid. So again, that perpendicular, that dot, 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 dot box. So the box is the height. Using h for the height, you can write a formula for the area of a trapezoid. Base 1 and base 2 are read as b sub 1 and b sub 2. I just say base 1 and base 2. So the area of a trapezoid is equal to half, 1/2 the height, times the sum of the bases. Here it is. 1/2 the height times the sum of those bases. So you're going to have to look for heights and base 1 and base 2. Would it matter if I called this base 1 and this base 2? No, because we're adding and it's commutative. Adding is commutative. So usually 99% of the time the little base is base 1 and the bigger base is base 2. So let's find some areas. Find the area of this trapezoid. Find the area of this trapezoid. So the formula, this is the longest formula, half the height times the sum of the bases. Okay, well the bases are always the pair of parallel sides. This side is parallel to this side. And the height, here it is, there's the box, is the perpendicular distance, and it's not dot, 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 because it's actually a side of this trapezoid. The height is 39. The base 1 and base 2 are the parallel sides, so you got to find the parallel sides. So this one's kind of topsy-turvy here, turned on its side. I'm going to call this one base 1, then I'm going to call this one base 2. I always label things on my pictures first. Then I go ahead and start doing my formula. Plug in what I know. Well, 1/2, I know that. The height is 39. 1/2 times 39 there. Use a dot or a parentheses. Base 1 plus base 2. Don't add them together. Show them as 13 plus 25. The next step, you're going to have to follow the order of operations. So I got 1/2 times 39 times 13 plus 25. So probably a good idea to add my 13 and 25 since it's in parentheses first. 1/2 times 39 times my parentheses 13 and 25 is 38. Half of 39, oh, that's not a nice number, but half of 38, that's 19. 19 times 39, well, 20 times 39 would be 780. Take away 39 would be 741. So half of, and yes, you can just take out a calculator. 1/2 times 39 times 38, that would be 741 feet is my label, looking back up here, squared. So 1/2 times 39 times 38. Formula, plug them in. Had to do a little extra step here, more work. Answer, label. This is the more traditional view of a trapezoid, and you probably can't see this. It's out cut off in the picture, but that height over here is 13 centimeters. It's labeled. There's my box. So I know that's the height, which means this is the parallel bases, the 10.6, which I'll call B1, and the 21, which I'll call B2. So formula, area equals 1/2 the height times the sum of the bases, base 1 and base 2. I don't know why it's writing squiggly. 1/2 of 13, that's my height. My bases are 10 and 6/10. and 21. Again, I could add 21 plus 10 and 6 tenths. Doesn't matter the order there. So I get half of 13 is 6.5, 6 and 5 tenths. And when I add my parentheses, I get 31 and 6 tenths. Okay, I better take out a calculator to do this one. And I get 205 and 4 tenths centimeters squared. 205 and 4 tenths centimeters squared. Okay, oh, this one's just drawn on grid paper. Well, the height here. Well, the straight distance down from a vertex, I could either draw my height right there, or I could take this vertex and go the distance to the opposite side down here, because that would be 90 degrees, and kind of extend this. Better to do it inside. So the height, that's my height. How many boxes high is that? 1, 2, 3, 4, 5, 6, 7. So my height is 7 units. My bases, well, from here over is 3. So I have base 1 is 3. 1, 2, 3, 4, 5. Yes, it does go all the way to that corner, so that's 5. So my bases are 3 units and 5 units. If I sum those together, I get 8 units. So half the height times the sum of the bases. So I get half of 7 times 8. Well, 7 times 8 is 56. Half of 56 equals 28 units. It's on unit graph paper, squared. Doesn't say anywhere on here like a key. Sometimes it does. It'll say, no, and it'll draw one box equals centimeters, or it equals feet, or it equals yards. Doesn't give you a key, so I don't know what the unit is that it's measuring. So it's units squared. 1/2 7 times 8, or 28 units squared. So, okay, so let's sum it up. This shape, I know we didn't do this shape, but it's a square, a square. It's got equal sides here. So they're all 7. How do you find the area of a square? Well, the area of a square, some people call it base times height. Some people call it side squared. That's what I call it. So base times height, they're all the same in a square, you know that. So 7 times 7, or 7 squared, that's why I like the side squared one. 7 squared is 49 centimeters squared. Squares aren't in the 6th grade book. You're already supposed to know those. Here's a square. The area is 36. Hey, what's the side? It's asking me what's the side if the area is 36. Okay, well, area equals side squared. 36 is the area. That equals side squared. Oh, what's the opposite of squaring to figure this out? Square rooting. Not dividing by 2. Square rooting. So that's our radical symbol. So we get 6, the square root of 36 is 6, equals the side. These cancel. That's your inverse. That's your cancel step. So 6 centimeters is the side. So the perimeter would be 6 plus 6 plus 6 plus 6, or perimeter would equal 4 times the side. Formula, plug in 4 times 6, or 24 centimeters. Not centimeters squared. I'm just going around and I'm measuring one length and one height and one length and one height. One-dimensional things. So it's just centimeters. My area is centimeters squared. So a perimeter and area of a square question. In a rectangle, as we see here, area equals length times width, or base times height. They gave me the, right? They gave me the area already. So really, area equals length times width. Well, if I already know the area, if I divide it by the width, I'll get the length. So that's what this says. The length is equal to the area divided by the width. So the area is 60. The width is 5. When I divide 60 by 5, I get 12 centimeters. So this is 12 centimeters up here. Little equation solving. And the last one, ooh, two shapes put together. What's the area of that? Well, what two shapes do you see there? Well, that's not a rectangle, that's a slanted rectangle. This is a parallelogram. I run out of space here. This is a parallelogram plus this bottom one down here, that's a trapezoid. So I'm going to just find each piece and add it together. Just like that. Parallelogram and a trapezoid. Ooh, lots of work here. This is what's called a composite area question. Composite, putting two of them together. So parallelogram, area equals base times height. Trapezoid, oh, plus. Parallelogram plus the trapezoid. Start over. Parallelogram plus the trapezoid. Area equals base times height plus trapezoid's formula, 1/2 the height times the sum of the bases. Okay, I have to write small here. The base of the parallelogram, oh, the box, box is 10, and the height is 13, base times height. So 10 times 13, that's the parallelogram. Plus the trapezoid, well, this base up here is 10. That base on the bottom is 18. Box, there's my height, is 12. So 1/2 of 12 times my two bases of 10 plus 18. Ooh, good order of operations questions. I have multiplying, adding, multiplying, parentheses. Well, I'm going to do my multiplying in parentheses. That's okay. So I get 130. Can't do the adding. No. Plus 1/2 of 12. I'm going to do that. Multiplying is 6. My parentheses times what's inside my parentheses is 28. So I've simplified my expression using order of operations. So 10 times 13, 130. 1/2 of 12 is 6. 10 and 18 is 28. 6 times 28 is 168. So 130 plus 168. My area of my parallelogram put on top of my trapezoid here, 298 inches squared. That was a hard problem. So be ready for area. We're going to talk about circles and circumference tomorrow.